Welcome everybody to today's webinar by the IEA SHC Solar Academy and hosted by the International Solar Energy Society, ICES. We are very pleased to have all of you here and we're going to get started now. My name is Arabella. I am the Congress Communications and Outreach Officer here at the ICES HQ in Freiburg, Germany, and I'm going to give you a short introduction into ICES and the work we do, as we have many new participants joining us on the webinar today. The International Solar Energy Society, ICES, is a non-profit UN-accredited membership NGO. Our vision is 100% renewable energy for all, used efficiently and wisely. ICES represents a diverse membership of academics, researchers, energy practitioners, consultants, students, businesses, and advocates. ICES works together with like-minded organizations from countries all around the world to advance the renewable energy transformation. There are many benefits to joining ICES, and you can always find more on our homepage. Some of the benefits are the exclusive access to presentations and webinar recordings, such as today's, in the ICES webinar archive. ICES members can also get discounts and even free registration to ICES events and partner events. Every month, ICES publishes a newsletter for our members where you can follow our progress and share your news. Members can also subscribe to our academic journal Solar Energy, our flagship publication, at a reduced price. And in the ICES online bookshop, ICES members qualify for reduced prices on the different publications. So we welcome those who are not yet members to join today to support our work. For those of you who are already a member, we thank you for your support. And as a special benefit to all attendees of today's webinar, we are very happy to offer a special discount when signing up with ICES as a member within the next 2 weeks. All attendees will receive a 20% discount code over the next few days, and if you sign up, the discount code will apply. Now, some brief information on the webinar for today before we get started. The webinar will present 3 presentations, and it will be moderated by Pedro Dias, and we will have a Q&A session at the very end. So if you want to send in your questions, you can start sending them in right away throughout the presentations, and then we will have one cumulative Q&A session at the end. And I'm now happy to introduce you to our moderator for today, Pedro. Pedro is the Secretary General of Solar Heat Europe, and he holds a management degree from the IPVC and has extensive experience in both the private and the non-governmental sector. In his previous field of work, Pedro focused on the heating sector, and there more specifically in gas retail and the commercialization of heating equipment. I am now happy to hand over to Pedro. Pedro, thank you for joining us, and the floor is yours.
Thank you very much for the introduction, Arabella, and thanks to ICES also for the opportunity to cooperate with this webinar once again. So it's a successful event that we are happy to cooperate on a yearly basis. So my name is Pedro Dias. I represent Solar Heat Europe. Many of you might know as ESTIF, the European Solar Thermal Industry Federation, but for already some years now we have renamed into Solar Heat Europe. So we are the trade association representing the solar heating and cooling sector in Europe. I'm very happy about cooperating with this webinar and the topic we have. And we have 3 outstanding speakers, as you know, Werner Weiss, Bärbel Epp, and Harald Drück. The webinar is foreseen to take 1 hour and a half, as you know. The introduction presentations will last approximately 1 hour, and then we have half an hour for the Q&A section. You can type your questions anytime under the question box, and please note that this will be addressed at the end during the period dedicated to the Q&A. So without further ado, I would like to introduce our first speaker. That will start with an introduction about the IEA Solar Heating and Cooling program and its Solar Academy, and then proceed for this presentation about the new edition of the Solar Heat Worldwide. So this first speaker is Werner Weiss. Werner is one of the most reputed experts in our sector. It has been for me a pleasure to work with Werner for many years now in the European Heating and Cooling technology platform, but also in his quality of founding member of the AE Intec in Gleisdorf. And many of you know that also Werner has been working for a long time at national, international level, so thermal and energy efficiency projects since the 80s. And in particular, and with relevance also for the presentation today, Werner is a co-author of the Solar Heat Worldwide report, and will later present us some of the findings. So Werner, welcome, and the floor is yours.
Thank you, Pedro, for the nice introduction. Just a second, I will show my presentation. So can you see it on the screen?
Yes, we do.
Okay, thank you for this feedback. Yeah, good afternoon or good morning, wherever you are. Before I start my presentation, I will give you a short introduction of the IEA Solar Heating and Cooling Technology Collaboration Program. This is one of the IEA research and development programs already established in 1977. So the Solar Heating and Cooling Program was one of the first research cooperations within the International Energy Agency. Currently, we have 19 member countries and the European Commission and 8 international organizations. At the moment, we are running 8 projects, so-called tasks, on a very broad range of topics, starting from renovating historic buildings, over solar water management, solar process heat, solar cooling for the sun belt, and it goes as far as daylight and electric lighting. About 300 plus experts worldwide work together in these 8 running projects at the moment. What you can see here on the map, the countries highlighted in yellow are the direct country members, and the 8 sponsors are highlighted in this brown color. And it's mainly representing the UNIDO centers for energy efficiency and renewable energy. So it's really a worldwide network. And 4 years ago, we decided to establish this Solar Academy because we wanted to transfer the knowledge gained in these tasks to the outside world or the interested public. So what we do is we organize these webinars held quarterly and hosted by ICES. As you know, today's webinar is on solar heating and cooling markets and industry trends, but we do it, as it mentioned above, it's quarterly to different task results. Further on, we produce videos, interviews with solar experts, and of course, all the past Solar Academy webinars are available on the website. Last but not least, we organize on-site and online trainings. These are training workshops on specific solar thermal topics, and they are provided by the IEA SHC experts. So that means if a new country, a member country, is interested in a topic or the results, we even go to this country with experts and do this training on site. Past trainings we had in the Caribbean, we had in China, in South Africa, and the UK. And this will be done upon request of the member countries. So this is basically what's the background of the Solar Academy. Here you can find more information. Just visit our website or follow us on social media. And if you have questions concerning how to join the IEA Solar Heating and Cooling Program, the best way is to get in contact with our secretariat. You can see the email address here. And at the end of the webinar, you should get also our slides so you can see all these contact details. This brings me to my presentation of today. As it was mentioned several times already, today we focus on solar heating and cooling markets and industry trends. And at the same time, we launch the Solar Heat Worldwide report. So the content of my presentation now, it will be possible to download it after this webinar from the website, which is highlighted in red letters on the bottom of this slide. You can download it. It's a quite comprehensive report of about 90 pages. So I will not be able to present everything what we have in this report, but I will show you the main highlights of the report of the edition 2021. So what's in this Solar Heat Worldwide report? We have the global market development and trends in 2020, and we have very detailed market figures from the year 2019 from 68 countries. So if you're interested in particular on data of installed capacity, square meter of different collector types, you just go in detail in this report. We published this report already since the year 2005, so we have really long time series, and my co-author Monika Spörk-Dürr and I do it together on behalf of the IEA Solar Heating and Cooling Program. This brings me to the solar thermal capacity in operation and annual energy yields. You can see here what we have achieved in the period between the year 2000 and 2020. You can see we started with about 62 gigawatt installed capacity in 2020, and in the year 2000, and in 2020 we reached 501 gigawatt installed capacity. So significant growth, and the annual solar yields related to this installed capacity grew from 51 terawatt hours the year 2000 to 407 terawatt hours in 2020. Nevertheless, I have to mention here at this point that the year 2020 showed a market decrease compared to 2019 of 4%. This is mainly due to the reason that China had a market decline of about -3% in the year 2020. But also strong European countries like Greece and Poland had unfortunately shrinking markets. But we have also good news. We have here, on the contrary, to the worldwide trend dominated by the huge Chinese market. We have countries with the highest growth rates in 2020, where Germany with spectacular nearly 26% growth rate, but also Brazil, Cyprus, the Netherlands, Turkey, the Palestinian territories, and Portugal showed significant growth rates in 2020. Before I go in more detail, I show you the top 3 markets for different applications. Just a quick overview. If you look on the top line, it's the solar district heating. We had the top countries concerning new additions in 2020 was Germany, took over from Denmark. So for years, Denmark was leading this market, but in 2020, Germany took the lead ahead of Denmark and China. If you look to solar industrial heat, the new additions came mainly in China, Mexico, and Germany. Concerning swimming pool heating, the most new additions were in the US, followed by Brazil and Australia. And then we have 2 applications where we show the total in operation systems or square meter. It's solar air heating systems, mainly used for space heating, but also for crop drying. It's in Canada, Australia, and Japan. And last but not least, an interesting new market from the last years is this PVD market, so photovoltaic thermal, in operation at end of 2020. France is leading ahead of South Korea and China. So this chart gives you hopefully a quick overview where we are, where are the leading markets. Still, small-scale solar water heating systems are the dominant market. If you look on the worldwide scale, about 60% of the total market worldwide is on small-scale solar water heating systems. On the top left, you see these typical pump systems like we have in Europe. And on the bottom right, the typical thermosiphon systems. Especially the pump systems are really very much under pressure for years now from PV and heat pumps. So that's a challenging market. But nevertheless, we have an area with consistent growth in the megawatt scale systems, mainly in solar district heating, but also in industrial applications and large systems for multiple family houses, public buildings, and so forth. What you can see here on this slide, shows you the time series starting in the 80s up to 2020. The bars show you the number of systems in Europe. These are the orange parts, and the red parts, the number of systems outside Europe, mainly in China. You can see for years it was dominated by Europe, but in recent years, a lot of systems were also, in terms of number, installed outside Europe. In total, at the end of 2020, about 470 large-scale systems with 1.7 gigawatt, corresponding to about 2.4 million square meters, were installed in these really large-scale markets, where the biggest subsector is solar district heating, which is shown here on this slide. A lot of you might know Denmark was leading this market for a decade with a total number of 124 systems for solar district heating with a capacity of 1 gigawatt installed capacity. This is followed by China with 18 systems, Germany with 43 systems, but on average smaller collector area per system. And then we have other European countries and Austria, Saudi Arabia, Sweden, Poland, the Netherlands, and so forth. But you find more detailed information in the overall report. But this is this large-scale megawatt sector for district heating. As I mentioned already, Germany took over from Denmark last year and took the lead. 11 of these solar district heating systems, which were installed in Europe in 2020, 7 of these 11 were installed in Germany, 4 in Denmark, 2 in Austria, and the largest solar district heating system in Germany was installed in 2020 in Ludwigsburg. This is what you see on this slide with a capacity of 1 megawatt. Another interesting solar district heating system was installed near Geneva with a capacity of just 0.5 megawatt. But why I show it to you, it's made out of high vacuum flat plate collectors, which is not so usual, but it has, of course, advantages if you want to produce higher temperature, especially for district heating. Another picture from Lhasa, from Tibet in China, installation with 11,000 square meter flat plate collectors, so an installation of 9.1 megawatt. The second subsector of large-scale systems is on large systems for residential, commercial, and public buildings. So as you can see here, these are what we mean here are neighborhoods where it's not district heating, it's usually something like block heating or big systems for hospitals, big systems for hotels, and so forth. And this is also a very quick growing subsector in large-scale systems. Here, China is leading with about 76 documented systems with about 300,000 square meters installed, followed by Turkey, France, Greece, Latin America, Austria, Switzerland, and Spain, and so forth. You can read it here on this chart. Shows you a little bit of a different market approach compared to the district heating, which is clear. For instance, Turkey and Greece, they don't have so many district heating systems like we have in Central or Northern Europe. But this is also a quick growing market on these large scale systems for residential, commercial, and public buildings. Just one slide for solar heat for industrial processes, because Bärbel Epp will go more in detail on these so-called chip systems. What we have documented so far is about close to 900 solar heat for industrial processes systems with about 1.1 million square meter collector area, which are in operation, and they range from small scale systems. So what we have in our statistics, starting with 50 square meters up to several 100,000 square meters and the 100 megawatt sector. And for 111 of these systems, we have detailed information available. So in terms of which type of collector is used in these systems, what are the temperatures used, and so forth. You find more of this detailed information in the report, but also on the website on this ship database, where you can see here this link to the website. What a lot of you might know, the world's largest ship system is an application in Mira in Oman. It's a thermal capacity of 300 megawatt. It's used for advanced oil recovery. But more on this ship system will be presented by Bärbel Epp in a few minutes. This brings me to one of two, in my point of view, quite interesting markets. It's PVT, photovoltaic thermal systems. What you see here on this slide is the Hilton Hotel in Cape Town, which has an installation of concentrating PVT systems with 103 kilowatt thermal and 17 kilowatt electric in combination with 4 times 44 kilowatt heat pump. Another type of PVT system is shown here. It's an uncovered PVT in Sao Paulo, in Brazil, also on a hotel, and it covers about 50% of the hot water demand of this hotel, and in addition, of course, electricity. How does this market develop? By the end of 2020, about close to 1.3 million square meter of PVT collector were installed with a capacity of 700 megawatt thermal and about 230 megawatt peak electric. This shows you also the range, order of magnitude between thermal and electric. So it's about 2 to 1, so 2 kilowatt thermal and 1 kilowatt electric. So it's about the ratio. The vast majority of this collector area was installed in Europe. Out of this 1.3 million, about 700,000 in Europe, about 57%. Then it's Asia, without China, mainly South, or a lot of this in South Korea. China 11%. And if you look on the European market, France is leading with 39%, Germany 9%, and the Netherlands with 5%. And we have a constant growth rate, annual growth rate of about 9% annually, which is quite interesting. So a stable growth rate. About 60%, that might be interesting as well, 60% of these collectors, the PVT collectors, are uncovered PVT, and 37% are air collectors, where the hot air is used as a source for the heat pump. So very often the systems are a combination of PVT and heat pump. And you can see here the market development in the different economic regions. An interesting development we observed, especially in South Africa, was what we call PV2heat systems. So there's the PV panels are directly connected to electric heater in the tank. So very simple system without inverter, so direct DC current directly heats up the hot water. So the electricity is used for nothing else, just for the hot water preparation. And with this very simple approach, it's a strong competition, in my point of view, to normal thermosiphon system. What's interesting in South Africa is the development of over the last 3 years. We can see it started with about 4,000 systems per year, and we are now in the range of 12,000 systems already installed by the end of 2020. So it might be an interesting development to follow. Last but not least, I want to show you, of course, you find in our report again, where are the top countries in terms of cumulated collectors. I think most of you know China is leading, it's by far the biggest market worldwide, and the different colors show you here the different types of collector. So in China, there's the dominance of evacuated tube collectors. If you compare it to Germany, for instance, here on the 4th place is flat plate collectors, the dominating market. So you get also an idea where are the markets. You can find it also per inhabitant, because the total capacity always shows the biggest markets, but per inhabitant you see something, you learn something about the market penetration. And this gives you a completely different picture. Here's Barbados is leading worldwide, ahead of Cyprus, Austria, Israel, Greece, and so forth. Last but not least, the distribution by type of systems of newly installed glazed collectors in 2019. I want to draw your attention just on the right bar. You can see 65% of the newly installed systems were pumped systems, and about 35% were thermosiphon systems. If you look back about 10 years, we had exactly the opposite picture, where we had about 60% thermosiphon and 30% pumped systems. This is due to a major change, especially also in China. Environmental effects, the contribution to the climate goals. With this 407 terawatt hours produced solar yields, we avoid 141 million tons of CO2, and this relates to 3.8 times the CO2 emissions of Switzerland, so you have an order of magnitude. With this, I thank you for your attention. If you're interested in more details, just visit the website of the IEA Solar Heating and Cooling Program and download the report. Thank you for your attention.
Thank you very much, Werner. So very interesting. So you provided us an overview of the evolution in different segments, such as large-scale systems and other segments, such as PVT. So I'm sure everyone has appreciated these, together with examples you showed of these such installations from around the world. And it's also very positive to see that the solar thermal market has recovered in 2020, in particular in comparison with 2019. Moving on, I have to say that being Portuguese, I have also recovered from the defeat against Germany 3 days ago. So I'm happy to present our two next German speakers. The first of which is Bärbel Epp. So Bärbel is a very well-known journalist. She's been covering for over 20 years the solar thermal sector. She's the founder and managing director of the agency Solrico, and also the editor for solarthermalworld.org, besides being also an author and collaborator in many different publications, and with the particular relevance also for the presentation today, for the solar heating and cooling market industry reports in the REN 21 Global Status Report. So myself and also Solar Heat Europe, we're happy that we've been cooperating with Bärbel in several of the interesting initiatives she's been working, and in recent years very much focused also on industry and solar heat for industrial processes. So I'm very glad and looking forward to the next presentation on the solar heating and cooling in industry and business trends 2020. So Bärbel, the floor is yours.
Yeah, thank you, Pedro. I will also share my screen. I hope all is visible.
Yes.
Well, okay. So my topic today is solar heating and cooling industry and business trends 2020. Well, interesting. Not moving again. Okay.
It has moved now.
Yeah, it moved. Yeah, I think it's a bit slow at the beginning. Sorry for that. Okay, we have done a lot of data gathering in the last months, and they concern two reports. One is the Global Status Report, as Pedro mentioned. The other one is the Renewable Power Generation Cost Report that is annually published by IRENA. The REN 21 report on the left is really a nice cooperation with the solar heating and cooling program, because Werner Weiss and his team contribute a lot of data to this report. And I have abstracted the content of it on the Solrico website so that it's easier to find. The IRENA publication was so far a pure electricity-driven report. It was sort of the Bible of the power cost generation. And we have succeeded to bring solar heat for the first time into this report. So they start with a chapter on renewable heat, and solar thermal is in the focus of it. So I will present some preliminary data from this. You cannot speak about the year 2020 without this little icon on the left, which is called COVID. I think Werner already mentioned some of it. We had a lot of postponed investment decisions by commercial clients that influenced markets, especially hotel and industries declined a lot. And we had declining or delays in installation and commissioning of already contracted projects. The reduction as in all of the added capacities in the global market were -4 only, say it this way. So it was a bit smaller than expected. And this has to do with two supportive trends, and I name them here: the higher demand from homeowners who spent more time at home and invested in infrastructure improvements. This was particularly, for example, the case in Brazil and Turkey. And then we have seen changes in policy support that had a much greater influence on demand than the pandemic itself. And this is Germany, Netherlands, and China, for example. So this is the core result of the REN 21 solar heating and cooling chapter. It shows the 20 largest markets, also in terms split additions, not global market, but the additions in 2020 of water collector technology. And what happens here is that all the markets that were in plus in 2019, to name, are Greece, South Africa, Tunisia, Mexico, Spain, and India, are now in the negative range. And this has really to do by the pandemic. Whereas the markets I named before, you see them here: Turkey, Brazil, Germany, and Netherlands are fairly nice in the plus. And China has done reasonable well with -3. They had much worse, well, declining rates in the past. And it seems that China really recovered in the second half of 2020 from the big breakdown or lockdown from the beginning of the year. And they had some supportive measures which really brought demand up. This is another outcome of the REN 21 data gathering. We questioned the largest flat plate collector manufacturers and we list them on this ranking without x-axis because some of the manufacturers are a bit tricky with seeing their absolute figures published. It includes national and international production volumes of these manufacturers. And there is a clear trend observed since several years that the gap widens between China's flat plate sector and the rest of the world. The Chinese manufacturers, the large ones mentioned in this chart, increased production volume by 12% last year, whereas the companies outside China, the total sales fell by 9%. And this is even with the nice increase in Germany that Werner mentioned, and which profited obviously the German manufacturers in this chart. So in China, it seems that there's a huge concentration going on, and the large manufacturers are even growing faster than the market itself. The flat plate collector market itself in China grew by 6% in 2020. And this has to do with bids, like governmental or private housing industry does huge tenders, and these huge tenders can only be answered by a certain number of large manufacturers, and the others sort of die out a bit with a decline in the residential small scale market. As you know me, I always like to talk about solar industrial heat. And all the results I'm presenting now are based on a SHIP supplier world map that we have built up within the Solar Payback project. You see, this is sort of the legend of the map where we find 4 categories of manufacturers. We have the ones with collector production, without, or with references and without. And you can search it either by typing in a country or a company name, or you just click on one of the markers, which you see here. They have these colors, as you have seen before. And there's a pop-up window going out where you see the number of references, you see how much collector area they have installed, but all related to SHIP. They might have other, large-scale systems in other applications, but we only count SHIP. And if there is, we also have a link to the ship-plants.info website that Werner mentioned, where particular plants are listed. This is the group of companies which is currently on the world map. This world map is annually updated, so only companies that responded to our survey remain on the world map another year. So we had to remove a lot of them, but we constantly get new ones as well. We have now 75 turnkey ship suppliers listed. Of these, 67 have their own production of collectors. And you see the distribution on the right. We have an increase, we have observed an increase of concentrating collector manufacturers over the last years. We have now 15 parabolic draft, 6 Fresnel, 4 times dish, and 2 heliostats. So this is 27, and this is really an increase in current years. All these companies together, the 75, are responsible for 1,000 turnkey ship systems. There are a few smaller ones included below 50 square meter, which doesn't count to our international statistics. That's why it's a bit of a different database than what Werner Weiss was saying. These are the turnkey suppliers with more than 10 references. And you see clearly that the hubs of this industry are in Mexico, in China, and in Germany. And you see that these manufacturers have a big variety of collectors. So you find them with parabolics, you find them with dish, with vacuum tubes, with flat plate collectors. So what makes the manufacturers from Mexico so successful? There are 3 of them in this ranking, and they all together have already installed 188 ship systems. And to answer this question, we can look into the cost assessment that I mentioned at the beginning with IRENA. And this is one of these curves, or well, point curve that IRENA publishes based on a database, which is now filled with 109 projects from Mexico. 5 suppliers contributed cost data, and 74 of them are ship plants. The rest is central hot water. You have stationary and concentrating collectors mentioned. And you see that the Mexican market, even it was already a mature market, declined costs, which is the left-hand side. You see weighted average installed cost by US dollar per kilowatt. This declined over the period of 10 years by 17%, which is a nice rate. And the levelized costs of heat, which are shown on the right-hand side, even declined further. So there was some maturity in yield or some improvements in yield by using better technologies. All in all, the 2020 figure on levelized cost of heat is 4 US cent per kilowatt hour, which is a very competitive price and makes clear why Mexico is very strong in doing these commercial plants. Well, the world market of ship, I have already mentioned some figures regarding that. We have done 4 surveys, so this shows you the development 2017 to 2020. The number of ship projects declined year by year from 207 to 74 last year. There's a high fluctuation in the installed capacity each year. This comes because of the Oman project that Werner also mentioned, the largest project in ship worldwide, which came in, into force or was commissioned in different phases. And the fluctuation of the figures mainly comes from India and Mexico. And to make this clear, I have pointed out in the bottom here the different figures, or like the number of systems in this year in the country. So like Mexico did, for example, 2017, 39, then 51, then 26, and now they do only 16. So India started with 22 and they are now at 3. So this caused a lot of this decline. So the overall market was as active as before, but the big markets where we started with 2017 declined. In India, this has to do with an investment program which stopped in March 2020. So a few more trends. What is a bit alarming that only 15% of the 75 suppliers listed on the world map have completed at least one ship project in 2020. This was 25 companies last year. So I think we have to really stress the fact that ship still needs a focus of policy support to reach higher deployment rates. India, we have seen the highest fluctuation, as I mentioned, because of this stop of the policy support. Currently, 7 companies are listed, but another 8 companies used to be part of former world maps and dropped and left the business already. And I think we will see this trend if not policy support is increased also in other countries, because it's evidence. If it's such a hard business and you can only realize every second year a plant, it's difficult. A new industry cluster have emerged in the United States. We have now 6 companies listed. The newcomers, you can check them out on the website. Sunvapor, Sulalux, and Skyven all offer concentrating collectors, and this has to do with massive R&D funding in California to develop low-cost concentrating collectors. I want to stop the ship side with a very encouraging result from our survey. We have asked the manufacturers the interest in green heating solution by multinational corporation, is it growing or not? And 60% agreed or strongly agreed to that. Only a very small portion disagreed. Some were a bit undivided, tend to agree, we left them out. And they also agreed, like more than 40% of them, environmentally conscious customers increase the pressure on consumer goods manufacturers to reduce their carbon footprint. So it seems that more requests are really coming to the manufacturers, to the suppliers of ship solutions. And we will see in the next years whether this materializes to more systems. Yeah, well, an interesting market that was mentioned by Werner, which really is growing and strong. It's the central hot water system market outside Europe, with the leading countries, China, Brazil, Turkey, and Mexico. The picture on the top is a Brazilian installation where flat plates are on a roof of the high-rise buildings, and the bottom one is a typical one from Turkey with a prison. And I would like to know or look back into this cost assessment to show you a bit why these systems are so successful. And what we see here now is a bit of a different chart. We have now gathered all projects that we have in the database for a particular country, not looking at a certain year, but for the whole period. And we have only listed levelized costs of heat. And you see the average line is the weighted average of this levelized cost of heat in a particular country. And below that, the average thermal capacity of the systems. And below that, again, the number of projects and the average yield. So you see that the levelized cost of heat in India and Turkey are really cost competitive with even $2 cent per kilowatt hour. Turkey seems to reach that with a and reasonable economics of scale by having 800 kilowatt as average size of the projects. But India probably has smaller projects, but is profiting from a certain share of swimming pool systems in this range of projects, and they have higher yields because of lower temperatures. You will see a different cost structure in Mexico and India. They have both the same size of systems, so no scaling effects play a role. They also have a bit of the same yields, but they have very different US dollar per kilowatt values, which have to do with probably labor and other reasons. And China is a bit out of range here because they have a lower yield in their systems, so they reach $4 per kilowatt hour. These are, again, preliminary versions of charts. Well, one last short introduction of trends in solar district heating, which I find really, really interesting. I think that solar district heating in Europe, at least, will be a game changer. We see very high interest of policymakers with generous funding opportunities in a lot of numbers of countries, growing numbers of countries. I have listed some here in brackets. And since I cannot go into details, I want to encourage you, if you want to know further, use Solar Thermal World, the filter function, which you see here. Choose a country, choose application district heating, and you will come fairly fast to one of these, latest reports that we made about new fundings, which is really enormous and will bring for sure interesting plans all around Europe. We have also competitive prices. The 6 Danish solar district heating systems in the IRENA database reach $4.5 per kilowatt hours. The average size is 12 megawatt. So a clear scaling, economy of scale effect, but a heat price that we have also seen in the chart before for systems in Mexico and other countries. So it's and this is Denmark, you know, so that's and Danish sun as well. So that's a very good price. And there's an interesting trend to be observed. More concentrating collector solutions will be seen in solar district heating in Europe and China. We have some announcements for European larger systems. And China, I want to share with you this crazy installation here. It's a 170,000 square meter parabolic draft field next to an amusement park, 82 megawatt. You see on the left-hand side what is like an airplane track or something is the parabolic draft field. It's installed in the north of China by the company Inner Mongolia, and you find the news already on the website, and we will report further on that. And this is how it's currently under construction. They started, I think, a year ago with the buildings, and now in summer they will start the parabolic field. This is not so spectacular, but a very important message from the IRENA cost reduction assessment. This shows the economics of scale for the district heating plants in the database, which are now 115. They are 97% of them are in Austria, Germany, and Denmark. The huge plant Silkeborg is included in the curve, but not on the chart. And we reach a 14% increase of cost per doubling of plant size. And there are first ideas that this could be also transferred to ship. So this is an important message to policymakers. If we do large, we can for sure bring costs down. So this was it from my side. I thank you very much for your attention, and I'm looking forward to the Q&A session.
Thank you very much, Bärbel, for this extremely interesting and groundbreaking presentation. I would also like very much to point out that I think the inclusion of the solar thermal in the IRENA's renewable power generation costs report is an important milestone for the recognition of the potential of large scale solar thermal systems. And this would not have been possible without your commitment and your tireless dedication. So thank you very much for that on behalf of our sector. I think I can say that. And so this leads us to moving on to the next presentation. And I'm particularly happy to introduce our next speaker, Harald Drück. So keeping with football, so in football terms, Harald will be considered a box-to-box player, such is the diversity of his skills and the range of his activities. Primarily, Harald is the head of the Research and Test Center for Solar Systems and head of R&D at the Institute for Building Energetics, Thermotechnology and Energy Storage, IGTE, which is in Stuttgart, so part of the University of Stuttgart in Germany. I personally also have the pleasure of working with Harald as board member of SolarIT Europe, and in parallel we have also worked on research and innovation topics in the ETIP as with Werner, but also on certification activities. So Harald is the honorary chair of the Solar Key Mark Network and is currently chair of the Global Certification Network. So, and more recently, we should also note that he's been indicated as operating agent of the newly initiated IEA SHC Task 66 on solar energy buildings. Therefore, I think it's easy to see that Harald is ultimately positioned to tell us about the market growth made in Germany. So, Harald, thank you very much, and the floor is yours now.
So thank you very much for your kind introduction, Pedro. I really feel honored by this. Ladies and gentlemen, also a very warm welcome from my side, and I am really happy to tell you about the solar thermal market in Germany, because there is a lot of good news to tell. So just a short overview what you can expect the next 15 minutes. I would like to give a short introduction to my institute. Then focus will be on the German solar thermal market, especially on the success factors, but also on a further success story that is to come. And I will also talk a bit about market threats, and finally also about quality assurance and product certification, and this context also with regard to the global solar certification network, and finally some summary and conclusions. As Pedro has already intensively introduced my person, I will not talk that much about myself, but about my institute, because it's a quite new one. In former times, it was called ITW. I can imagine that at least the ones of you that are in the sector for a longer time know ITW. A few years ago, we merged with two other institutes, and now we are the Institute of Building Energetics, Thermal Technology and Energy Storage. And we have several activities ranging from solar technology to energy storage, smart city concepts. We also run an accredited test center for solar thermal products and HVAC equipment, and some additional activities related to this. So now looking at the long-term evolution of the German solar thermal market. What can we see? We can see that in 2008, when a lot of people were talking at that time about peak oil, we reached something which I would like to call peak solar. So this was really a brilliant year with an installed thermal capacity of around 1,500 megawatt. That means 1.5 gigawatt in 1 year. And this corresponds to around 2.1 million square meter. And of course, everybody thought things will accelerate, things will go on like this. But what happened was exactly the opposite. So the market declined. And the market declined for a really long time. And this market decline for around 10 years was, according to my assessment, mainly due to extremely attractive PV feed-in tariffs. Because the subsidies on solar thermal, they were there and they were not fundamentally changed. There were some changes in this period, but no fundamental changes. But yeah, the market really went down from year to year because the feed-in tariffs for PV were extremely attractive at that time, but now they are reduced, or they were continuously reduced. And what is also, I think, from a psychological point of view important, with PV, you were able to earn money because you got money for the feed-in of electricity, but with solar thermal, you can only save money. And of course, earning money is more attractive than saving money. But now things have luckily changed. Feed-in tariffs are extremely small now, so focus is on self-consumption. That means also not earning money, but just saving money with PV electricity. And then in 2019, we really reached the absolute minimum, or as a mathematic guy, I know it's not the absolute minimum because that's here somewhere. It's the relative minimum. So we reached the relative minimum with around 500,000 square meter of collector area that were installed. And this corresponds to a thermal capacity of around 360 megawatt, which is approximately a quarter of what we had in 2008. But the good thing is things changed. And now we got what Werner already mentioned. We got this increase by 26% from 2008 2019 to 2020, and 2020 we ended with around 500 megawatt installed capacity, corresponding to around 650,000 square meter of newly installed collector area. And the good thing is the success story continues. What is here plotted based, all this data are provided by the two associations that are active in the German solar thermal sector. It's BSW and BDH. And what is plotted here is the sold collector area in the first quarter of the year. And there you can also see that from 2020 to 2021, there is an increase of 23% already achieved. And I think there will be much more to come in the coming quarters of the year. Now the question is, of course, what are the success factors that lead to this turnaround? And I think the most important aspect, beside the decrease of the feed-in tariffs for PV, is that by the end of 2019, a new subsidy scheme was introduced. And this subsidy scheme is extremely attractive because you get around 30% of the eligible costs if a solar thermal system is added to an existing heating system. You get 40% of the investment cost if an old oil boiler is replaced by an efficient gas burner combined with a solar thermal system. And you get even 45% if an old oil boiler is replaced by a renewable heating system. And as renewable heating systems, biomass burners and heat pumps are considered. But to get this 45%, you have to combine them with a solar thermal system. And what is also very important is that these subsidy rates, they are based on the total eligible costs. And these total eligible costs, they nearly cover everything. So if you are going to install a new heating system or a solar thermal system, and you have to modify your space heating system to be able to operate it at lower temperatures, for example, installing a floor heating system or wall heating system, which is extremely expensive, then these are also considered as eligible costs, where 30% or 45%, depending on the option you choose, is reimbursed by the federal state of Germany. So extreme attractive subsidy scheme at the moment. If we look what types of systems are subsidized by this program, then in 2020, approximately 11,000 systems were subsidized according to this incentive scheme, and 75% of these systems are so-called solar combi systems, providing hot water and space heating, and they have an average collector size of around 11 square meters. So it's a bit small, but anyway, it's a combi system. And 25% approximately are solar hot water systems. And then what is also interesting, because it's a growing market, around 3% of the systems are for so-called solar active houses. This term is also in the subsidy scheme, and solar active houses are houses with solar thermal fractions above 50%. And there we still have 3%, and the market is growing. And what is also interesting is that for 42% or 42% of the newly installed solar thermal systems were combined with a gas burner. But this is also due to the fact that you are in general not allowed to install a gas burner only, because you have to cover a certain share of your heat demand from renewable sources. So, and this is already nice. It's a success story. And the next success story that will come is related to large-scale systems. In this context, large scale means collector areas larger than 1,000 square meters. And if we look what we can expect here, then that means based on different scenarios and systems already in preparation, this market will also increase. But what is plotted here is the total installed collector area, so not the annual installed one, but the total installed one is of course impressively increasing, and the annual installed one is also increasing by around, or it's not increasing, but approximately around 50,000 square meters of large-scale systems are annually installed, and that means depending on the size of the market, if you assume this 600,000 square meters, or if you go for 1 million square meters, it's in the range of 5 to 10% of the total installed collector area in Germany that will be dedicated to large-scale systems. So everything is bright, everything is nice, the sun is shining on a blue sky, but I think also some clouds already appear on this sunny sky, and these are the solar obligations. And these solar obligations I really consider a threat for our market, because in many federal states and cities, so-called solar obligations are now implemented or are under discussion. But in many cases, these solar obligations, they are de facto PV obligations, because they require the installation of PV panels on the roof of new buildings or fundamentally renovated buildings. And of course, such PV obligations, even if they are called solar obligations, they are a kind of killer for solar thermal technology. And I mention this because I can imagine that in your city, in your country, this discussion will also pop up about solar obligation. And then please be aware of the threat. And if you have the chance to contribute to these discussions, then I recommend to promote technology neutral solution. That means solar obligations requiring the installations of solar thermal systems, PV systems, or a combination of both. Then I think it's a fair competition. So what is also important is, of course, quality assurance and product certification. And that means that we need high quality products as a key factor for long-term market success. And high quality products can be ensured by using only certified products in the contents of incentive programs. And it's clear you cannot build economy for decades on subsidy. That means more and more these incentive programs and subsidy programs will be replaced by legal requirements. But then also it's important that only certified products are considered as eligible. And I recommend to use well-established certification schemes for solar thermal products like Solar Key Mark in Europe, or SHC in the US, or Golden Sun in China, or Watermark in Oceania. And in this context, I would also like to mention the Global Solar Certification Network, because it's also resulting from two IEA tasks, task 43 and 75, performed within the solar heating and cooling program. And there we established this Global Solar Certification Network as a cooperation between leading solar thermal industries, certification bodies and inspection bodies, as well as test labs. And this global solar certification network aims to facilitate worldwide cross-border trading of high-quality solar thermal products. It helps to avoid retesting and reinspection of production lines. It's especially interesting for manufacturers entering new markets. And the latest news, the Global Solar Certification Network has this spring established an alliance with the Solar Heating Initiative for the global implementation of the Solargy label. I think this is also a very important step forward. And by all these measures, we aim at increasing the quality, reducing the costs, and get better market and better business. And if you are interested in further information about the Global Solar Certification Network, then go just to gscn.solar. And with this, I come to the end of my presentation. I would like to summarize. If appropriate boundary conditions are provided, solar thermal markets can grow. But this means, and this is really important, that we need fair economic conditions between different renewable energy technologies. In the past, we had a situation that in Germany, PV systems, if you take the feed-in tariffs into account, were subsidized by a factor of 10 more than solar thermal systems. And then I think it's completely clear in which directions the investment goes. So what we need is a fair economic playing field. We need also appropriate legal frameworks. That means real solar obligations and not PV obligations. We also need awareness with regards to investors and users for our technology. We need certified high quality products. We also need skilled and experienced installers and for sure some things more. But then we can make it. And finally, what I think is very important is that no climate neutral energy system without considering the heating and cooling sector will be possible. So it's not all about electrification. And what is also important is that no climate neutral heating and cooling sector without solar thermal energy will make sense. And with this, I thank you for your attention. And I'm also looking very much forward to the Q&A session.
Thank you very much, Harald. And thanks for bringing some sunshine from Germany, with which good developments have been warming the sector in Europe, and also to remark the different treatment that is given to different RES technologies. I share that it is essential that at a political level there is the need to ensure a level playing field between RES. So we need to promote all RES, all renewable energy sources, but we need to do it fairly and not distorting competition. So thank you very much also for bringing that warning message, let's say. Which we take as a yellow card for politicians. Let's hope it doesn't become a double yellow. We go now into the Q&A. We have approximately 20 minutes to do so. And I would start by asking Werner a question from Karim Noureddin. So what do you think is the main hindrance for solar heat usage in sun-rich countries in MENA, in specifically Egypt, Morocco, and Jordan? Werner, please.
Yeah, in general, I think that the MENA countries have quite a good established market, especially concerning thermosiphon systems. So I think there we have really a good market, especially if you look to Tunisia. But in other countries, I think, in my point of view, what's missing is a constant support for this technology. So awareness on policy level on solar thermal, and usually I a little bit hate the term solar water heating system. This is used in a lot of these countries, so it reduces the application of solar thermal just for small scale water heating system. Much more can be done. An excellent example for me was Jordan some years ago. There was an initiative from the government to put solar thermal systems on major hospitals. And then immediately you see companies are interested in coming up and installing systems. So main obstacle is awareness on policy level, also on the broad range of applications, especially in the sun-rich countries concerning cooling, but also industrial process heat. This is very often not seen on policy level. It's reduced on to what they have in mind on small-scale water heating system, which is important, but shows just a small part of the whole picture.
Thank you, Werner. So next question to Bärbel. Is the influence of different regions, technologies, and systems, including in the learning rate for district heating that was presented in the cost report?
Yeah, this is actually a nice question. Brings me to the ARENA methodology. We have looked first into, well, what I said is solar district heating projects from Germany, Austria, and Denmark are included in this cost curve. And you know, ARENA was first a bit doubting whether it's good to bring two countries into one cost curve. But then what they did is they calculated cost curves for all three countries, and it worked and it was solid. And then they said, okay, if this is solid, then we combine them and we see a logic, you know, European solar district heating curve. And this is what we presented now. And it's a solid calculated curve, 115 projects, but it's only including flat plate collectors and a few vacuum tube systems, not concentrating. If this was one question.
Yeah, I think it's clear. Thank you very much, Bärbel. Going to Harald, there is a request for clarification on the presentation. So on the prognosis on slide 8, there was no expectation for an increase in industrial applications of the solar systems in Germany. So could you please reflect on the reasons for that?
I think it all depends, of course, on the boundary conditions. And with regard to this, I think there is an increase, but compared to the increase of the other sectors, that's not that significant. That's why it was not plotted.
Okay,
it was plotted,
thank
but
you.
Could not see it.
Okay. Next question, again for Werner. So the asker is asking, so do I understand it right that the roof applications are still more in surface in Europe than large scale systems?
Yeah, roof applications. So if it's meant it's integrated in roofs or built on existing roofs, of course, this is very common in Europe, especially for single family houses, multiple family houses. I think it makes a lot of sense. The collector area is the roof, so replacing the roof tiles. With this, you also can reduce the cost of the installation. On the other hand, there's a big discussion I know from my country in Austria, especially in the direction of ship systems and district heating. District heating systems, it's not at all possible to put it on roofs, so distributed on different roofs. There we need ground-mounted systems. And I think there will be a big discussion in the upcoming years on land availability, not just for solar thermal, but also for PV. I can see it here. We have these political goals to have 100% of electricity produced by 2030. So that's tomorrow, more or less. So a lot of space is needed for windmills, for PV, and nobody wants to have it in front of his house. But everybody agrees it has to be done. And the same is for district heating. I think there will be a big discussion on land availability, especially if we go for these large-scale systems. And just one sentence more, for ship systems, we have very often the idea, no problem at all with ship systems, we put it on flat roofs of the industrial halls. We looked for it for, I think, something like 2 decades now. This is also limited because the additional weight on the roofs, I don't say it's impossible, not at all, but it's at the current stage is overestimated what is possible. So I expect major discussion on land availability for all renewables.
Okay, thank you, Werner. Next question to Bärbel, and if the speakers also want to comment, Werner in particular, which is also related to the report. So, what is the major concern regarding the decline of solar thermal market in India, besides policy?
Well, India, as I said, was a fairly stable and always a slight growth market. And the latest decline we saw was really pandemic oriented because they had lockdowns and they had travel restrictions, and the end customers couldn't really get to their systems. And they have, but besides, in the commercial segment, it was this concern with the policies, but they also have a strong discussion going on vacuum tubes and quality. This is an ongoing fight, so to say, in India, because a lot is imported and there's not much restrictions on like standards on the vacuum tubes which are shipped from China. And so sometimes I hear that suppliers are not able to sell because they don't have permission, and others are questioning them because they have unsecure quality. So the whole issue of quality is really troubling India, whereas the government had very ambitious targets, many years back. I think they were one of the earliest countries that did targets. So it's a mix of, and the policy lost a bit interest, we must say as well, because of the quality issues. So it's like they're circling around this problem, and it's a bit sad to see from outside, at least.
Okay, thank you very much. Next question is to Harald. So what is the danger of a non-climate neutral policy for solar thermal? Is this related to concerns that solar thermal technology is obsolete?
I think it's a very wise question. If we have a non-climate neutral policy, we will of course have a lot of risks and dangers, but what is the danger for solar thermal? I think the danger, or one danger for solar thermal, could of course be that depending on the prices of the fossil fuels, and fossil fuel prices are related to non-climate neutral energy supply systems, solar thermal, but also maybe other renewable energy technologies might be too expensive. But of course, this depends on the level to which the fossil fuels are subsidized, or to which extent CO2 tax is applied on these fossil fuels. So I think it's all about prices. So that means there is no general answer. It depends on the different price levels, I would say.
Okay, thank you very much. Werner, so question is, in the future we'll need only or almost CO2-free heat production systems. Which could be the role of solar thermal in decentralized systems? Combination with heat pumps, with hydrogen or biomass? So what is your opinion? We cannot hear you.
Especially, sorry, I've had to unmute. I think there is a huge sector for solar thermal in future, especially in making district heating systems renewable. There is no other source available, so we have limited resources depending on the country in biomass, but I guess it will be a combination of biomass and solar thermal in district heating, especially because we have the infrastructure and you can basically feed into the already existing infrastructure. I'm also convinced if we go to seasonal storages, as we know it from Denmark, for instance, that we have to combine solar thermal with high temperature heat pumps in order to use the storage capacity better. So here I see really a very quick growing market if we want to go to 100% renewables in the heating sector. There are not so many possibilities in the heat sector if we don't believe that we can electrify everything, because this would mean a huge demand of renewable electricity, which I don't see in the near future. So I think there is a good possibility, but where I see the problem at the moment is that we have not enough companies who do really turnkey systems. If many companies, even if they claim to be turnkey providers, usually they want just to sell the collector or sell the collector field, and not doing really system integration, what is needed, how to combine it with a heat pump, and to come up with a total system approach. And this is missing. And here the companies have to be quick to take this huge piece of market, which I see for solar thermal.
Thank you. The next question was originally addressed to Bärbel Epp, but I would enlarge it also to Harald Drück. So what do you believe are the main R&D needs in the future for SDH when considering the ARENA and REN 21 reports? So Bärbel first.
Yeah, well, challenging. I think it's Harald placed, but I want to answer even so. I think I see three topics from what I usually research. Integration schemes, you know, improving the way how you get the heat to the customers, especially in for industry, and standardization is very important, so that you don't have to go over and over planning steps every time. And compact storages, which are still far beyond, you know, 2030 even. We don't have concepts, and there's, from my point of view, too little money available for developing them. But third, communication. It's not an R&D topic, but we need better communication about solar heat by all players. Harald.
Thank you, Bärbel.
You're the real researcher.
Yeah, but I can in principle confirm what you said, Bärbel. I also think it's about standardized, not only integration scheme, also installation schemes. So standardized concepts, plug and play is a very important aspect, also to reduce labor cost, to ensure error-free installation, things like this. Then, of course, a hot topic every time, cost reduction. I think is important. Even if the costs are quite low, they can be much lower, and there is a need. And then I also agree with you with regard to the storage aspect. And there, yeah, I think it's on one hand a question of available R&D money, but on the other hand, it's also a question about commitments from the industry, that they really see advanced energy storage as a future business case, and due to this decide to invest, because there are a lot of promising technologies in the pipeline. And then, even if it's not an R&D aspect, what I think is also very, very important is bankability and all this stuff to get this money that is needed for these huge investments.
Thank you. So next question to address to Werner. Could you comment on the usability of solar thermal systems in cold climate regions with lots of snow? I guess in Austria you have a bit of this issue, so you can speak with property.
It's not really an issue. So usually, if the question is what happens with snow, usually on the days where you have snowfall, there's very low radiation. And this relates to PV as the same way like for solar thermal. And usually one day after snowfall, it slides down from the collectors, because usually in our climate, collector areas usually are inclined with about between 30 and 45, 50 degrees, which fits also to usual slopes of roofs. So this is not really an issue at all. Even high up in the mountains, we don't have these very flat roofs. And we have very good experience. On the other hand, more and more architects take it into the facade, especially if you go for space heating. Then it's even, we did some years ago, measurements and monitoring. We got excellent outputs, even better than on the roofs, because of the snow reflection in the facade, if you use it for space heating. So this is not really a major issue.
Okay, thank you very much. So next question I would also direct to Harald and Bärbel. So it's related to ship projects in Germany. Which growth rate can be expected in the next years? So the €1,000,000 question.
Pedro, I want to grab this first because there's one question in the chat and I need to answer that because I don't want to be misunderstood. I haven't showed a learning curve. This must be very, very clear. I have showed an economy of scale curve, and this is heaps of a difference because I was asked here, usually learning curves have 20% in common. Why does my learning curve have 13%? We have also calculated learning curves. And the difference, I think we really have to learn this as a sector, is a scaling curve can be immediately realized. So you do a system today, which is 10 megawatt, and you do in the same year 20 megawatt, and it's just specifically lower, less expensive because of, you know, like soft costs are cheaper because you have less trucks and, you know, you have less logistics and so on. This is the effect on scaling. But learning curves are over time. It's learning by doing. And you have maybe better purchase agreements, or you have better lots of factors, you know. And we have calculated them, and they had 12 and 17%. So what I showed is a scaling effect, which has really only to do with size and is static, can be realized immediately, and learning curves are over time. Sorry for interrupting your questioning, but it's important to make this clear. Otherwise, the charts are misunderstood. And now ship. Well, ship is a difficult question in Germany, but Harald, you can go into that. My problem is that we have very nice funding since 2012, but we don't have really a turn up in systems. And my feeling is that this is a lack of the supply chain in Germany, and I'm a bit more optimistic than I was 2 years ago because of my questioning that multinational corporations are really requesting, you know, like offers. And since I heard that, and this is repeated by a lot of suppliers of my world map, I feel that now they must react. So I hope that we see larger projects in Germany and therefore a learning curve and more effects on that, also more visibility for politicians. This is my hope, but I don't know whether it will materialize. Harald, what is your assessment on that?
I think it's extremely difficult to predict the future, but what I think, and this is, I'm fully in line with you, Bärbel, I think we have the technology, we have a lot of initiatives. We also have, I would say now, excellent subsidy schemes. They are close to what is allowed by the European Commission. That means 50% subsidies of the investment cost. And now what I think is new since this year is that we have this CO2 tax. And I think this could, of course, help to boost the systems because there is an additional benefit for the industry that did not exist in the past. And so I would say if the boundary conditions are that good as they are at the moment, and if the CO2 tax will even be increased, what is under discussion now, then I hope that we can see something in the double-digit growth rate, which is, of course, at a lower edge, like 20% or something like this. But yeah, I think this is what I think could be realistic.
I think this is a good way to finish with a message of a double-digit growth rate. I think it's a good tone to leave from this. So I want to thank the speakers for the enlightened presentations, and I would also like to thank everyone for attending the webinar and for your interesting questions. So from my side, I would also like to thank the IEA Solar Academy, in particular IEA, SHC, and ISIS for the invitation, and for the work they have been doing in the different webinars they've been organizing, which everyone in the sector, I'm sure, is very thankful for. So this is from our side. I hope you enjoyed the webinar, and I will now pass the baton to Arabella for a final message. So thank you very much, and please keep safe. Thank you.
Thank you.
Thank you, Pedro, and thank you to our speakers for the presentations and the audience for the questions. I think we had a very fruitful and very good discussion today. And before we close for today, there are a few final announcements I have for you. We get asked a lot. Yes, there will be a webinar recording. It's going to be available both on the ISIS as well as the IEA SHC Academy homepage in a few days. We always need a few days to edit everything, but then it's going to be up there for you. For our ISIS members, remember you already have that handy dandy thing that is the ISIS webinar archive. So all presentations and all recordings are in there already for you. And then there's another biggie coming this year for ISIS, and I think for everybody on our webinar here today. That's the ISIS Solar World Congress, and we are actually welcoming, or we are very happy to have the IEA SHC program again as a key partner for that event. And so this event is going to take place in late October. It's going to be an online congress. Yeah, and registration for that is going to open very soon, we think July. So you can head over to our homepage already, get informed there. And I think I'm very sure I'm going to see our speakers there again. And I think I will also see many of you attendees joining us in October. So we are very much looking forward to that. And with that, I'd like to close for today. There's going to be a little survey that's going to be sent out to you. We very much appreciate if you could fill that out for us, because that helps us in providing these webinars for you. And again, a big, big thank you to the audience and of course our speakers. And I think with that, we're going to close for today. It's bye-bye from me in Freiburg in Germany, and I hope everybody is going to have a nice rest of their day. Bye.